Today, we're going to talk about one of the most important physicists of the 20th century, Erwin Schrödinger. Erwin Schrödinger was a renowned Austrian physicist who made significant contributions to the development of quantum mechanics. He is best known for his work on the Schrödinger equation, which is a mathematical equation that describes the time evolution of a quantum system. Schrödinger was born on August 12, 1887, in Vienna, Austria, to a family of intellectuals. His father was a botanist and a professor at the University of Vienna, while his mother was a painter. Schrödinger's early interests were in physics and mathematics, and he began studying these subjects at the University of Vienna in 1906. After completing his undergraduate degree, Schrödinger went on to pursue his PhD in physics at the University of Leipzig. He completed his doctorate in 1910 and then worked as a research assistant at the University of Berlin. In 1914, Schrödinger was appointed as a professor of theoretical physics at the University of Zurich, where he remained until 1921. During his time at Zurich, Schrödinger began working on the development of quantum mechanics. In 1926, he published a paper titled An Undulatory Theory of the Atom, in which he proposed a new way of understanding the behavior of atoms and subatomic particles. Schrödinger's theory used wave mechanics, which was a novel approach at the time, to describe the behavior of particles at the atomic and subatomic level. This idea was a major departure from the classical understanding of physics, which described particles as definite objects with definite positions and velocities. Schrödinger's wave mechanics was a key component of the development of quantum mechanics, which is a theory that describes the behavior of matter and energy at the atomic and subatomic level. Schrödinger's work was controversial at the time, and it was not widely accepted by the scientific community. However, his ideas were later confirmed by experiments conducted by other physicists, including Werner Heisenberg and Niels Bohr. In 1933, Schrödinger was awarded the Nobel Prize in Physics for his work on quantum mechanics. He continued to work at the University of Cambridge until his death in 1961. Schrödinger's contributions to physics are still widely studied and used today. His work on quantum mechanics has led to many important technological innovations, including transistors, lasers, and computer chips. In addition to his work on quantum mechanics, Erwin Schrödinger made several other important contributions to the field of physics. Here are some of his notable contributions. Schrödinger's equation. Schrödinger's most famous contribution is the Schrödinger equation, which is a partial differential equation that describes the time evolution of a quantum system. The equation is a central equation in quantum mechanics and is used to describe the behavior of particles at the atomic and subatomic level. Wave-particle duality. Schrödinger's work on quantum mechanics helped to establish the concept of wave-particle duality, which states that particles can exhibit both wave-like and particle-like behavior depending on how they are observed. This idea challenged the classical understanding of physics and helped to establish quantum mechanics as a fundamental theory of physics. Quantum field theory. Schrödinger's work on quantum mechanics also laid the foundation for quantum field theory, which is a theoretical framework that describes the behavior of fundamental particles and their interactions. Quantum field theory is a crucial tool for understanding the behavior of subatomic particles and has been used to make many important predictions in particle physics. Unified field theory. Schrödinger was also interested in developing a unified field theory, which is a theoretical framework that describes all of the fundamental forces of nature in a single framework. While he was not successful in developing a complete unified field theory, his work helped to lay the foundation for modern theories such as supergravity and superstring theory. Statistical mechanics. Schrödinger made important contributions to the field of statistical mechanics, which is a branch of physics that studies the behavior of systems with many particles. His work on statistical mechanics helped to establish the connection between thermodynamics and quantum mechanics and led to a deeper understanding of the behavior of systems at the atomic and subatomic level. Color theory. Schrödinger was also interested in the study of color theory and its relationship to physics. He published several papers on the subject and developed a theory of color perception that is still widely used today. Philosophy of science. Schrödinger was also interested in the philosophy of science and published several papers on the subject. His work on the philosophy of science helped to establish the importance of quantum mechanics as a fundamental theory of physics and helped to challenge the classical understanding of the universe. Overall, Schrödinger's contributions to physics were wide-ranging and helped to establish quantum mechanics as a fundamental theory of physics. His work continues to be studied and used today in fields such as particle physics, condensed matter physics, and quantum computing. Schrödinger was a complex and fascinating person, known for his intelligence, creativity, and sense of humor. He was also known for his love of animals, particularly cats, which is reflected in his famous thought experiment, Schrödinger's cat, which is a paradox that illustrates the strange implications of quantum mechanics. Today, Schrödinger's legacy continues to inspire new generations of physicists and scientists. His work has had a profound impact on our understanding of the universe and has paved the way for many important technological advancements. Thank you for watching. If you have any questions or comments, please leave them in the comments section below. And don't forget to like and subscribe for more videos about the history of science and technology.